sigma rho, where sigma greater than rho. Area of cross section of cylinder, let it be A. This everything is a liquid. I just release with the lower end touching the free surface. Then what will be the velocity of this cylinder when it gets fully into the water? So what is our question? Our question is this much. So once when it gets fully into the water, what velocity it will acquire, final velocity. Volume immerse will come, so V naught will write it. Afterwards, what will happen? The velocity of this will remain constant. Also, like the velocity will keep on increasing later part. So I want this V naught. I'll release it. Why it will get into the liquid? Because the condition of the density of solid will be greater than density of liquid. So definitely it will sink, no? So here it will accelerate. Okay, what are the forces that is acting? Weight of the solid, some x length or the y length is immersed. Then the buoyant force will be. Let's get into the calculation part. So what is the question? Find V naught. Once the cylinder gets fully into the liquid, what is the speed of the cylinder? Okay, let's write equation now. Ma is equal to Ws minus Fb. What is M? M should be equal to sigma Ah into A. Oh, sigma Ah into A. What is the weight of the solid? Sigma AHG. What is the buoyant force? Rho Ay into G. So what is the expression for acceleration? What we get, I think A gets cancelled. Sigma Hg minus rho Gy by sigma H. So this will become G minus rho so this is the expression for the action. Okay, but what is asking is asking a speed. So this acceleration, I can write it as V dV by dy. G will be rho G by sigma H into Y. No, initially it is released from rest. V naught 0 to H, 0 to H. First we'll calculate Y, then in the end I'll write it H, that one. Let's see the nature of it. V square by 2 Gy rho Gy square by 2 sigma H. Okay, this is the expression for the speed of the look at the speed. Will it increase or decrease? Speed of this rod, will it increase? As it is getting into the liquid, the speed will increase here. What will be the acceleration? Increases or decreases? So if you plot the graph, the variation, the graph will be of this kind. This is for acceleration. The moment you release, put y equal to 0, then how the graph will be? The graph, what happened, will take shape like this. Then afterwards, it will be constant. It will have uniform acceleration. And this is what? H. How to interpret, sir, what you are writing actually? What is that graph? Look at the acceleration, put y equal to H. it got fully into the liquid, no? Because this is what y equal to 0 will define. The moment you release, what happens? The weight will act. The weight alone will act equal to g acceleration. Fine. So now as the cylinder gets into the liquid, the buoyant force magnitude will increase. So therefore the acceleration decreases, but speed will be increasing. Speed will continuously increase. Then once it gets fully into the liquid, the acceleration will be constant. How to tell that? Put y equal to h. So what is the acceleration will be? G1 minus rho by sigma h. So what is the value of this acceleration? So these are the types of small based concept questions can be asked here. So initially it will have variable acceleration. What is the type of motion of the block? Decreasing acceleration, increasing speed. Afterwards, uniform acceleration, constant speed once it gets into liquid. So now it's asking what is the speed V naught. So V naught, for V naught, what we should do? V naught is equal to 2gh rho g h by sigma. Okay, there's the value of the speed once it gets fully into the liquid. Now at that instant only, again what happened? Due to acceleration continues to increase. So what is V naught? Speed of the cylinder when it gets fully into the liquid. So what is the buoyant force? Buoyant force depends upon volume inverse. Volume inverse continuously varying. So therefore, definitely what happens? The net force acting on the cylinder